We're at the end of Chapter 3, so it'll be time for a test next week. I'd like to go back today and use it as a review for the beginning of the chapter, since it's been a while since we've done estimation, measures of central tendency, formulas, but of course we recently did equations with decimals, so I'll just focus on the first couple for today's lesson. We talked about several ways to estimate, mostly rounding, some front end with adjustment, and clustering. I'm going to focus on rounding and clustering. When I'm rounding, you'll be told what place value to round to. I'll make things easy for these practice problems, and let's round to the nearest whole number. And then we'll either add or subtract. In the first one, I'll round 8 5/10 to 9, 3 4/10 to 3, and 4 9/10 to 5. And then I'll simply add. In the second one, I'm going to round to the nearest whole number again, and that'll be 24. And I'll round to the nearest whole number, and that'll be 12. And I'll subtract. When we talked about clustering, we focused on finding numbers that were clustering around or in the same area. They were all pretty much near each other. I'm looking at 11 8/10, 10 4/10, 11 2/10, and 10 7/10, and I'll say they're all around 11. I count up and I see there are 4 of them, so this is approximately equal to 44. Let's see that again. 31 4/10, 29 4/10, and 33 2/10. They're all around, I'll say 30. There are 3 of them, and I'll just multiply, and I'll get approximately 90. Now with estimation, reasonable answers are accepted, but these are the most reasonable that I would say. We then went from sums and differences to products and quotients. With products, we were rounding to the same place value. So in most cases, if they're single digit numbers or single whole number digits here, we'll round to 5 times 6. It's approximately equal to 30. Second problem, we'll round to 4 and 8, approximately 32. In my last problem, rounding to the nearest whole number will give me 12 times 4, approximately 48. Quotients were a little different. We were rounding the divisor, and then we were finding a compatible number. 4 8/10 is 5, rounds to 5. I think about numbers near 41 that are close to 5, and I'd say 40, and that's approximately equal to 8. Rounding the divisor gives me 6 in my next problem. I'm thinking of the 6 times table. I'm thinking that 6 and 36 are close here, so we're going to say this is approximately equal to 6. And there we have some practice with our estimation problems, estimating sums, differences, products, and quotients. We then talked about measures of central tendency, words like mean, which was the average, add them all up and divide by the number of terms. We had the median, which is the middle number when ordered from least to greatest. We had the mode, a number that might appear most often. There could be one, more than one, or none. We talked about range, where you subtract the lowest number from highest. And we use this word outlier as a data number that's much higher or lower than all the rest. Let's put that to practice. Here's a set of data. Find the median. Think about median as a middle. But if there's an even number of data items, we need to find those two middle numbers, add them together, and divide by 2. So count up the data, 1, 2, 3, 4, 5, 6. There are 6 data items, which means that it's an even number. What I need to do, very importantly, is order them from least to greatest. I always double check. I started with 1, 2, 3, 4, 5, 6, counting 1, 2, 3, 4, 5, 6. I have an even number. If I cross off each one on the side, I'm going to see that I have 2 numbers in the middle. I'm going to add them and divide by 2. My median is 11. Second question. Find the range of the set of data. Now, it's not necessary, but it is helpful to arrange the numbers from least to greatest in order to find the median, to find the mode, to find the range. But you can do this without if you prefer. If I'm looking across, I want to find the greatest number, and I want to subtract from that the lowest numbers. Okay, so it's the lowest from the highest. And I'll see that will give me 24 as my range. Mode, a number that appears most often in a set. Well, I have 1, 2 5s. I only have 1 8. I have 1, 2 4s. And it looks like I have 2 modes. What are those 2 modes? 4 and 5. Outliers, numbers that are either much higher or much lower than all other data entries. Looking across, it looks like there is an outlier, and that outlier is 8. So there you have some practice on our measures of central tendency. We then went on and talked a little bit about formulas, and we'll do that one in class.